In today's video, let's see the chemical properties of chemical tankers. Atoms. All atoms consist of a nucleus and a cloud of electrons that move around the nucleus. The nucleus is a cluster of two sorts of particles, protons and neutrons. The atomic number of an element is equal to the number of protons in its nucleus. The atomic weight of an element is the average mass of its atoms on the scale on which one carbon atom weighs 12 units. The periodic system and period table. The periodic system was initially drawn up by the Russian chemist Mendeleev in 1869 as a means of linking the properties of groups of elements to their atomic structures. The elements whose atoms have two outer shell electrons are picked out and called group 2, and so on with group 3 and 4. Finally, the groups are arranged side by side to form the periodic table. Chemical reactions. A chemical reaction is a change in which one or more chemical elements or compounds, the reactants, form new compounds, the products. All reactions are, to some extent, reversible, i.e., the products can also react to give the original reactants. However, in many cases, the extent of this back reaction is very slight, and so the main reaction is considered irreversible. Hydrocarbons. Hydrocarbons are compounds of carbon and hydrogen. A vast number of different hydrocarbons exist, with alkanes and alkenes being among the main types carried on ships. Gaseous hydrocarbons. If we look at the formulae for some of the hydrocarbons, we can see that those hydrocarbons with up to 4 carbon atoms are gaseous at ambient temperature and pressure. Liquid hydrocarbons. As we move from butane, gaseous, to octane, we can also see that liquid hydrocarbons containing between 5 and 20 carbon atoms are liquid at ambient temperature and pressure. Solid hydrocarbons. Hydrocarbons with more than 20 carbon atoms are solid at ambient temperature and pressure. An example of a solid hydrocarbon is bitumen. Saturated hydrocarbons. Saturated hydrocarbons consist of carbon atoms that are bonded by single bonds and where all valencies, the number of hydrogen atoms that the atom can combine with, are occupied. Unsaturated hydrocarbons. Unsaturated hydrocarbons contain one or more double or triple bonds. They contain less than the maximum quantity of hydrogen. This instauration can be satisfied by reagents other than hydrogen, and it gives rise to the characteristic properties of unsaturated compounds. Olefins. Unsaturated hydrocarbons containing one or more pairs of carbon atoms linked by a double bond are known as olefins or alkenes. They react by adding other chemical agents at the double bond to form derivatives or polymers. Aromatic hydrocarbons. Aromatic hydrocarbons contain a benzene ring in their molecules, or have chemical properties similar to benzene. Halogenated hydrocarbons. These are hydrocarbons that contain one or more halogen atoms, that is fluorine, chlorine, bromine or iodine. Alcohol molecule. The structure formula of an alcohol is formed by replacing a hydrogen atom from a saturated hydrocarbon with a hydroxyl, OH, group. The name is formed by adding the suffix OL to the name of the corresponding alkane. Acids and bases. The positively and negatively charged ions of an acid conduct electricity when dissociated in water. The relative acidity of a substance is indicated by its pH value, which may range from 1 to 7, the neutral point. The lower the pH, the stronger the acid. A base, or alkali, is a compound that reacts with a protonic acid, an acid that forms positive hydrogen ions in aqueous solution, to give water and a salt. The relative alkalinity of a base is indicated by its pH value, which may range from 7 to 14. The higher that pH, the stronger the base. Litmus paper. Litmus paper, which is carried on board chemical tankers, is used to determine the pH value of solutions, principally after tank cleaning. The presence of an acid in the solution turns the litmus paper a shade of red. The pH value can then be determined by comparison with a color calibration chart. Similarly, the presence of an alkaline solution turns the litmus paper a shade of blue. The higher the pH value, the deeper the shade of blue. Self-reacting chemicals. There are many chemical cargoes which are chemically self-reacting, such as ethene and styrene. Self-reacting cargoes can cause polymerization, where molecules join together to form polymers, e.g. ethene becomes polyethylene and styrene becomes polystyrene. Decomposition, where the chemical reaction causes a compound to break down into simpler compounds or into elements. Inhibitors and catalysts. To prevent self-reacting cargoes either polymerizing or decomposing while still on board the tanker. Inhibitors, stabilizers, or catalysts are used to stabilize the cargo for a short period of time. The presence of an inhibitor in the liquid cargo may not prevent reactions within the ullage space. Chemical data extracts. This extract from a chemical data sheet for epichlorohydrin outlines the chemical data in the form of the formula and the chemical family to which it belongs. This, in conjunction with the compatibility chart, is used in key early planning stages for the voyage to determine where that cargo may be carried. Thanks for watching. Hope you like this video. Let us know your questions or comments in the comment box below. For more such videos, subscribe to MarinAura.